Welcome, colleagues. Today we're diving into this explainer to look at how the study of unidentified aerial phenomena, or UAP, has firmly transitioned into a legitimate, data-driven science. For decades, this subject was kind of stuck on the absolute fringes, clouded by secrecy and a whole lot of stigma. But as we're going to see today, modern science has finally stepped in. We're going to treat this exactly like what it is, a rigorous academic briefing on how we apply high-level scientific research methods to unexplained detections in our skies and seas. Let's get right to it. I think this quote from the Galileo Project really hits the nail on the head. Our goal as researchers is to completely shift away from fringe speculation and rely purely on rigorous, transparent methodologies. It's no longer about isolated eyewitness accounts or, those grainy photographs taken by chance. The new standard requires us to move past legends and anecdotes, demanding transparent, validated, and systematic scientific research. We're building a methodology that strips away all the noise and looks only at what the hard data can actually prove. So just to give you a quick roadmap of our briefing today, we're going to cover the era of UAP science, public records and transparency, multimodal instrumentation, cross-referencing and artifacts, imagery analysis and action, and finally, the future of UAP research. All right, Section 1, the era of UAP science. Let's dive right in and establish exactly what it is we're studying here. It's critical that we share a unified vocabulary before we can discuss the data. According to the official government definition from the 2023 National Defense Authorization Act, UAP represent anomalous detections across multiple domains that currently exceed positive attribution. Notice the terminology shift here. We're no longer just talking about flying objects. The term has been broadened to unidentified anomalous phenomena to encompass airborne, seaborne, spaceborne, and even transmedium objects. The key identifier for us is that they display performance characteristics or behaviors that our current sensors and observers just cannot immediately understand or attribute to known actors. And recent literature reviews demonstrate that studying these phenomena is no longer an exclusively American or anecdotal pursuit. It's truly become a rigorous, global, scientific inquiry. When you look at comprehensive academic reviews analyzing data from 1933 all the way to the present, scientists across Scandinavia, France, Japan, and the Americas are actively mobilizing. The information gap is closing, folks. We're realizing that to solve this puzzle, we don't need better stories. We need high-quality, curated databases managed by actual information science experts. Moving on to Section 2, public records and transparency. This shift to legitimate science has been totally accelerated by an unprecedented era of public records transparency. We simply cannot conduct a proper scientific investigation if the foundational data is locked away in classified vaults. Looking at this timeline, we can really trace the reporting trends from historical pilot observations in the 1940s and 60s straight through to the landmark 2024 establishment of the National Archives' UAP records collection. For example, newly released Pentagon files document a 1947 Pan Am flight crew momentarily spotting a bright orange object. And even Buzz Aldrin, during his 1969 Apollo 11 debriefing, mentioned a sizable object near the lunar surface. But the real game changer is the modern era. We go from the 2015 Navy forward-looking infrared videos to the 2024 mandate forcing federal agencies to transfer their UAP files into a completely public National Archives collection. It's a huge step. Now, it's absolutely crucial to ground our expectations in the data. The government explicitly notes there's no evidence of extraterrestrial technology, emphasizing that unidentified simply means our sensors didn't collect enough information. The All-Domain Anomaly Resolution Office, or AARO, states this incredibly clearly. We cannot rush to conclusions. When an object is labeled unidentified, it's really just a reflection of our sensor limitations at that specific moment in time, not necessarily a confirmation of the extraordinary. And honestly, this brings us precisely to our core scientific challenge. That brings us to Section 3, multimodal sensor instrumentation. How exactly do we solve this fundamental problem of insufficient sensor data? Well, the answer lies in how we design our observation platforms. As outlined by recent academic blueprints, eliminating false positives requires a very specific suite of multimodal and multispectral hardware deployed at ground-based observatories. You simply can't rely on a single camera anymore.
You need wide-field multiband cameras for tracking, and you've got to combine those with passive multistatic radar to determine actual physical range and kinematics. Plus, you need radio spectrum analyzers, ultrasonic microphones, and crucially, localized environmental sensors. Because only by capturing a phenomenon across the entire electromagnetic, acoustic, and environmental spectrum simultaneously can we confidently verify that a detection is a true physical event.
And this perfectly highlights the fundamental flaw of the old paradigm. Single-sensor anecdotal data is just way too prone to optical illusions, glare, and distance distortion. But when you have multimodal, multispectral data, where your radar, optical, infrared, and acoustic sensors are all corroborating the exact same spatial coordinates and velocities, you literally eliminate the possibility of a single-sensor artifact. That's the gold standard we're aiming for. Let's jump into Section 4, Cross-Referencing and Artifacts. Capturing the data is really only half the battle. Interpreting it correctly is where the actual science happens. So our data validation process requires these very strict steps. First, capturing the initial physical signature, then immediately cross-referencing it with environmental wind or thermal data. And finally, systematically evaluating it to rule out sensor display errors or video compression issues. When an anomaly is detected, the very first thing we do is pull the local weather telemetry. We ask, what's the wind speed at that exact altitude? Are there any thermal inversions? By applying these rigorous peer review standards, researchers systematically filter out the everyday airborne clutter. A brilliant example of this methodology in action is the 2018 Mount Etna case. A forward-looking infrared video captured an object that appeared to fly straight through a superheated volcanic plume in Italy. I mean, it looked incredibly anomalous at first glance. But by coordinating international analytical efforts and pulling the precise telemetry, researchers realized the intense atmospheric conditions were actually creating a massive optical distortion. It turns out the object was 170 kilometers away, traveling exactly at wind speed. It was just a prosaic balloon optically warped by a volcano. This is why cross-referencing environmental data is absolutely vital. All right, Section 5, Imagery Analysis in Action. Let's transition over and see how these exact methods are applied to resolve officially declassified military imagery. This is where we put the theory to the test against actual field reports. It's frankly fascinating to see how seemingly anomalous visuals are practically resolved in the field. Take case PR016, for instance. In 2023, an infrared sensor in Europe picked up objects with a really strange pulsating heat signature, but by analyzing the morphological consistency and matching that pulsation frequency to known avian wing beats, researchers resolved it, with high confidence, as birds. Similarly, a fast-moving object showing trailing cavitation in South Asia was resolved as a commercial aircraft, once experts determined the so-called wake was actually just a video compression artifact. It's like a giant puzzle, and the data gives us the pieces. So the crucial point here is that to officially classify a case as resolved into one of these mundane categories, researchers require a greater than 95% likelihood that really demonstrates our field's incredibly high threshold for confidence. When we say an object is, say, a consumer-grade reflective foil balloon, like in a recent 2024 Middle East case, it's because the behavioral correlation with recorded wind speeds and morphological features leaves less than a 5% margin of doubt. We don't just guess. We rely on the math. But what happens when an object's morphology is unremarkable, but it lacks that multimodal telemetry? Well, like several recent European infrared cases, it remains unresolved. There's an entire catalog of cases spanning from 2021 to 2024 where a thermal contrast is observed, but we just don't have the accompanying radar or environmental data to make that 95% determination. But here's the thing, we don't throw that data out. It goes straight into the database to help us map out geographic hotspots and refine exactly where we should be placing our sensors next. It still contributes to crucial locational trend analyses. Finally, Section 6, Future of UAP Research. We've established the baseline, so what is the strategic roadmap for the international scientific community? Well, our strategic focus has got to remain on expanding our global sensor networks to capture physical objects, engaging data curation experts, and continuing to leverage public transparency to close that information gap. The era of the lone investigator looking up at the sky is officially over. We need the library and information science fields to manage these massive influxes of public records at the National Archives. We need continuous deployment of multimodal field stations, like those proposed by the Galileo Project, operating purely in the transparent, peer-reviewed mainstream. As we close out this explainer, I want to leave you with this thought. As our multimodal observatories systematically filter out the noise, the balloons, the birds, and the sensor artifacts, what will the remaining, rigorous, verified data reveal next? The scientific method has finally arrived for UAP, and honestly, the real discoveries are only just beginning.